little bit of geometry, practicing all the time in between. To find, first of all, the angle F1. Now let's have a look at the question first, because it didn't say anything on the papers that I gave you, but it would have said O is the center of the circle. It would have said that the lines are straight lines, etc. And it would have said CE and BF are parallel to each other. So I would even make it nice and highlight it for myself so I can't not see it. Because definitely I'm going to use that for sure. Alright. And the only thing that they've given me is 2x there, which is a what? Angle at the center. Now, let's get cracking. Where's your 9 theorem? Right, line from the center of the circle, perpendicular to a chord. Is that one there?
No.
Could be.
Yeah, because there's a center.
Where? There. But it's not given perpendicular, so I can say half-half, and it's not given half-half, so I can say perpendicular, but maybe. Line from the center, perpendicular. Then, the second one is angle at the center, twice the angle at the circumference. Do you think it's there?
Yes.
For sure. Angle at the center, subtended by.
Wait, ma'am.
CB, circle. CB to the center. CB to the
Center. To the east.
circumference. Where is going to be the circumference? So that will be,
And also,
because the angle at the center is 2 times the angle at the circumference.
circumference.
But what about A? Why?
Because of
It's also on
side.
CB and also going to the circumference. So it's still angle at the center twice the angle at the circumference. Do you see it?
Yes, ma'am.
From those 2 points, going to the center, going to the circumference. And what about bow tie? Bow tie.
So,
Because all of them mix up together. You can't get for the one answer x and the other one's 3x. It has to be the same. If you get the relationships the same. So, angle at the center twice the angle at the circumference for both of them, or you could have said if you found the one, the other one is with the bow tie, which is
Angles in the same circle segment.
angles in the same circle segment. Now that's only 2. So the third one was the semicircle, which I'm helping you with now because I see you've forgotten.
yes.
Semicircle?
Isn't it bad?
Isn't there even one diameter? Because that's what you're looking for.
Okay,
There is AB, but it doesn't make an angle at the circumference, so it doesn't help. But then we get to number 4, which is the bow tie, which we've already seen. But is there only one?
No.
Where's more?
I feel like C is equals to
Say
B.
B.
3 is equals to C1.
Ah.
These
Please don't make a lot of things on the sketch before you actually find out what's going on and do it in a pencil so you can erase. But you see the bow tie?
Yes, ma'am.
Definitely. So I'm still not quite there yet. Okay. So there's 4 of them. Then question. Theorem 5 and 6, remember? Cyclic quad. Are they cyclic quads?
Yes.
For sure. Which one?
2 of them.
2 of them. You believe?
Yes.
A,
C,
C,
F, B, and C,
and
C,
C, E,
B, F.
B. What about C, O,
It's not.
B, F?
Doesn't touch it.
Exactly, guys, like you were taught. So there's a cyclic quad, of which I can know opposite angles are supplementary. I'm just seeing this now.
So meaning F1 will be X.
Would be what?
180 minus X.
That's why they said find it in terms of
X.
X. And there's the answer. 4 marks. What did you all have to do? First one? Which one?
So,
A.
yes.
Couldn't it have been this one as well?
You could have.
Then you would have used that cyclic quad. And still say opposite angles are supplementary.
Supplementary.
An exterior angle,
Yes.
look at the ACFB.
Uh,
Exterior, if you extend it, the exterior one would be opposite
X.
that one would be a.
X.
and also
And in
B1.
any case, it's a straight Are you with me?
Oh, nothing.
And from this side as well. Opposite angles or exterior angles. Alright, so let's get started at least. So we said that angle A, because that's the one that we were mentioning now, would be XY. Angle of the center, twice the angle of the circumference. Which is 2 marks, guys. And then F1 would be 180 minus X. And your reasoning tells me everything. Because it's opposite angles of a,
Cyclic quad ACFB.
I like it, of cyclic quad ACFB. Why would you have to say that? So that the marker can see your funky way of doing it and follow what you've done, if you did it a funky way. Right, the second part of the question says, please prove that DF and BD are the same length. DF and BD.
DF?
DF and BD.
She said, oh, DF and BD are equal. So maybe we need to find B1, and if they're equal, then it's isosceles
Yes,
triangle.
exactly on track. Yes. If I want those 2 lines to be equal to each other, what I'm trying to find from you is that when will they be equal?
When there's an isosceles triangle.
That's when they'll be equal. So, that's what she said. If I can find B1 is equal to X, then I'm done. Because it's sides opposite equal angles. But why is this X? Not because of isosceles triangle, because it's not. Why?
It's 10. So you need to
Corresponding angles? Yeah. Or what about exterior angle on that cyclic quantity? Are you with me, guys? There's so many ways to do it. But I like that. To say B1 would be the same as angle E. Oopsie, but I never said what E was. So if I didn't say it yet, I can't use it. So then I'll have to first say if E was equal to X, Y. Because a bow tie, please don't write bow tie, it's
And same circle segment.
right? Careful. You might have said it there, but you haven't written it yet. So you need it before you can use it. So I need that E, and then I can say that they are both equal to each other, because I've already said it there. Both of them are equal to X. Because these are
EC is parallel to BF.
remember, if that's not there, you don't get the mark. Corresponding alternate co-interior has to have that additional little tail side there. And if they are equal, then those sides will be equal. Then BF will be equal to BD. Why?
They're most opposite sides, opposite equals
Okay, you
angles.
got there. Sides opposite equals
angles.
It's important. It's not angles opposite equal sides. It's sides opposite equal angles. You've just proven the angles. So the sides opposite to the equal angles are equal. Careful. If the angles are equals, then the sides
Are equal.
opposite the equals angles are equal.
So
Right.
if you prove
Right, number 3, they ask, prove that C1 and C3 are equal to each other. And we're going to have enough time here. C1 and C3 must be equal to each other. Do I know either which one of them? Prove that they are equal to each other. C1 must is equal to B3, okay?
and then the
Let's
whole
try.
then wait.
So I need to know what that is.
So
Some
when
sort
we
of
put
way.
C2 and 3,
Ma'am, isn't the whole of C23X because of corresponding angles? And then,
Yes, go.
ma'am, I can't.
No, you can. You just said it. The whole of this is equal to X. You saw this.
Yes.
Ah,
yeah. So
because of the parallel lines. They are
Supplementary.
co-interior angles that are supplementary. So the whole thing is x, but what does that help me?
B2 and 3 is equals to 180 minus x.
B2 and 3.
Yes. Because of
Yeah, okay. This is that, yeah.
Then
Okay.
And then you're gonna do angles in a straight.
We're going to do interior angles of a triangle because
Which
E
one?
is equal to B.
Sorry, E
Oh no.
and B. Just yeah. I like it because it's an actual value. So that one is x and that one is x because of what?
Alternate.
Are you quite sure?
No.
no, can't.
No.
Can't.
You're thinking up, but it's there. Those would both be x. Here's my alternate angles. Are you with me, guys? Right, and it even looked like it. Yes.
I don't wanna go.
To do what?
They're gonna give us an isosceles. They're gonna give us an isosceles triangle.
I love it. I love it. There's some knowledge coming through here. Definitely. These
Isosceles.
are
Radii.
radii. So this
Therefore,
whole angle,
is equals to that whole angle.
which is what?
X.
Okay, now here comes the tricky part. So if the whole angle is x, and this whole angle is x, and they got a PC there in common,
So
so they have to be equal to each other. So if you'd like to call it, say for instance, A, then what's this piece here?
B.
X minus A.
X minus A. And if this whole thing is x and this is A, you don't have to save it, but think about it. If the whole thing including C2 is the same as the whole thing including C2, but C2 is the same thing, has to mean that the pieces there have to be equal to each other. So now how are we going to write that? Because you can't write PC. Okay? So we're going to say, what he said is that A, C1 and 2, and please guys, you know that you don't write that. C1 and 2 together must be the same as A, which is X, because of radii being equal to each other, and then angles opposite equal,
Sides.
sides different from that one. Then if that whole thing is X, and we said that the other one was X yet? Somewhere. So we have it. Why was this X? Because we should say that C2 and C3 must also be equal to X because of co-interior angles. That's what she said. Right? Co-interior angles being supplementary. Now, if you don't write that again now, I'm not going to deduct marks from you, but write it every time. Okay. Now I want to show you. Can you see that they are equal? That they're equal to x? And that's the same? What are you deducting?
So you can see one.
That has to be the same. For what reason?
Oh, hey, we don't need
Look, that's your reason. Are you with me? C1 and 2 together gives you x. C2 and 3 together gives you x. But C2 is the same thing, so that must mean that those two are the same. No reason. It's a logical deduction that you're making there. Okay, but that was tricky. Now, last question. They say if DF is 5 centimeters, okay, let's go back to the sketch. If DF is 5 centimeters and OA is 6 centimeters, OA, 6 centimeters, so that will mean that this is also 6 centimeters, agreed?
Yes.
Right? Since we know that already. Calculate the area of BFD. Oh my goodness. Which tools are you using for area of a triangle?
area. Half base times perpendicular height.
Can it be half A, B, and C?
Yes.
Can it be half base times height?
Yes.
Okay, now let's look at this question. To find this area of BFD, which is this one, and AOC. That's what I want. I want this area in ratio to the other one. Say it's 2 to 3, double, half, or whatever. So this one I also know, now remember the sum follows on each other. This one we said that this is going to be equal to each other. Okay? So the area of this triangle and the area of that triangle is going to have some sort of a relationship. But no, the only thing I know is that the sides of these two sides are 5 and those two are 6. Okay, so now if I work out an area of a triangle, could it be half base times perpendicular height for this sum?
No,
Where's the perpendicular height? I
there is
don't
no
have anything.
perpendicular height.
It'll have to be for BDF, will have to be those two sides, 5 times 5. Alright? So I think I'm going to have to erase it here so you can see. So area of triangle BFD would be half. And please give credit where credit is due. Give me the area rule. So it'll be half times, but you've got a problem, right?
We don't have any
Because what is that angle D?
180 minus 6.
Oh, fantastic. But I don't have that. How can I do that on calculator? Okay. Is everybody happy?
Oh,
on
yeah,
this?
yeah. Yes, ma'am.
You
It's
with me,
an
yeah?
angle of a chair.
Ooh, and it's a proof sum.
Yes.
In geometry,
Yes.
okay, but now I'm stuck. I think I'm stuck. But let's go have a look at the other one.
Where is that?
The other triangle, AOC, would then be half of, you don't have a choice. The only stuff you have is
Oh.
6 and 6. Are you with me? Also 2 sides and the included angle. 2 sides, included angle there is what? Also, this is x and x, 180 minus 2x. So if I say do BFD area in ratio to AOC's area, then you put this equal to that. You can simplify, but just look at it. It's going to be half times 5 times 5 times sin of, I'm so frustrated that I can't do this yet. Okay, dot dot, and half times 6 times 6 sin. I just want to do that reduction formula, I just have to do it. But look at it. Remember that a ratio is basically a fraction. So top and bottom can cancel out. So why can't I cancel this out? I can. And?
Okay.
It is true that it is going to be sin 2x. Because proof goes away. Second quadrant sin is positive. It is so. But again, sin 2x here and sin 2x there are going to disappear. Because it's like it's on a fraction and they can cancel out. So what's left?
6.
That's it. That's the ratio of the one triangle and the other triangle. This is such a pretty sum. Okay, so our next sum would be number 6 for next time.